Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is creating a new function by binding. Before proceeding, make sure that you have already watched these other videos first. One callable object can be transformed into a new one by binding. The newly created callable object does not have any name. It is merely a compiler temporary, returned by the call to bind. The binding transformation can pass along a parameter from the invocation to the target function. You might wonder, why go through the bother of binding into a new function when we could have just kept using combine AABBCC as the value for combine? Well, for one thing, binding allows us to dynamically change parameter order. Consider the value that's going to get passed into parameter A. It used to be that value could only come from the first invocation parameter, which happens to be 11 in this invocation. But now we can choose to have parameter A's value come from the third invocation parameter instead. In this invocation, the third invocation parameter happens to be 33. We have this freedom to control the source of all the parameters. Binding could even ignore some of the invocation parameters, providing some completely different parameter value for the target function. In our previous example, the new parameter value introduced by binding was a literal. It could have been any C++ expression, including a variable like this ivar. However, such a variable would not be captured. To understand what that means, consider that there are several interesting points in time. Of course, first there is compile time, which is when we're compiling the program. Then during runtime, our program flow will eventually reach the location of this bind. It is at this binding time when we evaluate the expression ivar. At this point in time, that expression's value is 22. Thus, the binding will act the same as if we had used a literal 22 here. Later on, program flow will reach the invocation. At this invocation time, when the target function is getting called, we give it that value of 22. It does not matter that, by now, ivar's value has already moved on and has been changed into something else. You could instead have captured the ivar variable. Then, at invocation time, a constant reference to ivar will get passed to the target function. Consequently, the fact that ivar's value is 33 at invocation time will be seen in the result. We've already seen how a binding's expression could be a literal or a variable. It could also be a nested function call. If you want that nested function to be done at binding time, then write it as normal. If you want that nested function to be done at invocation time, then capture it by writing a nested binding. Any placeholders written within a nested binding will refer to the outermost level. So in this example, the first invocation parameter, which is 3, gets passed to the multiply by 11 function, and that function's result is given to the C parameter of combine A, B, B, C, C. An overloaded function cannot be in a nested binding because of the ambiguity that would result at binding time. Recall that a member function can be a callable object value. A member function can be bound the same as any other function. The this pointer can be provided either at binding time or at invocation time.